Assalamualaikum Doctor. My name is Muhammad Faris Haikal bin Nur Effendi. I am from Group 8. Today I would like to present my ultrasonic testing. Okay, ultrasonics detect flaws or changes in material characteristic by transmitting high frequency sound waves into the material. The most popular ultrasonic testing technique is pulse echo, in which sound is injected into a test object and reflections from internal flaws or the part's geometrical surface are returned to a receiver. Ultrasonic testing is a type of testing that employs high frequency sound energy to perform inspections and measurement. Ultrasonic inspection may be used to discover and evaluate flaws, measure dimension, characterize material, and more. A pulse or receiver is an electronic device that can generate electrical pulses of high voltage. The pulse drives the transducer, which produces high frequency ultrasonic radiation. Sound energy is injected and propagates in the form of waves through the material. When there is a break in the wave, such as a fracture, some of the energy is reflected back off the defect surface. The transducer converts the reflected wave signal into an electrical signal, which is then shown on a screen. The reflected signal intensity is shown against the time from signal production to when an echo is received. The advantage of ultrasonic inspection. For fault discovery of measurements, the depth of penetration is preferable to other entity approaches. Second, when using the pulse echo approach, only single-sided access is required. It is quite good at estimating size and shape and calculating reflector location. There is very little component preparation required. Instantaneous findings are provided via electronics equipment. Automated system can generate detailed pictures. In addition to fault identification, it may be used for thickness measuring. Ultrasonic inspection has its limits. To transmit ultrasound, the surface must be accessible. The level of skill and training is higher than with some other approaches. To facilitate the transmission of sound energy into the test specimen, a coupling medium is usually required. It is tough to evaluate materials that are rough, uneven in shape, very tiny, extremely thin, or not uniform. Due to limited sound transmission and significant signal noise, inspecting cast iron and other coarse-grained materials is challenging. It is possible that linear fault parallel to the sound wave will go unnoticed. Both the calibration of equipment and the characterization of defects require reference standard. Ultrasonic vibrate travel in the form of wave and similar to the wave light travels. There are four modes of sound wave propagation. The first one is longitudinal wave, second transverse wave, third surface wave or relic wave, and fourth plate wave. Longitudinal wave is parallel to wave direction, and transverse wave is perpendicular to wave direction. Relic wave is elliptical orbit symmetrical mode, and plate wave is component perpendicular to surface as stationary wave.
I am Muhammad Fahdi bin Fazil 143909. Okay, I will talk about test technique. So I will show you about 4 test technique today. First echo, second two transmission, net, contact and emission, and the last one is normal beam and angle beam. Okay, we will talk about pulse echo first. Pulse echo utilize the reflected part of the ultrasonic wave. Both are on the same side of the material. Give the location of the tip, either one or two port can be used. Where two transmission utilize the transmission part of ultrasonic wave, both are on the different side of the material. Do not give the dip, for example, the right location of the dip, and two ports are used on opposite of the material at the same time. Normal beam and angle beam. Normal beam testing. The sound beam is introduced into the test article at 90 degrees to the surface, where angle beam testing the sound beam is into, into the test etiquette at some angle other than 90 degrees, like 45. The decision between normal and angle B expression in normal is normally made based on two factors. First, the rotation of the feature of interest. Second, observation of the part surface technique to be walked through. Contact and immersion. Immersion equations are performed in a liquid that carries the sound beam between the pod and the test material. The contact approach involves running an ultrasonic testing probe over the test free surface while emit the sound wave through a tiny layer of gel compliant. Emission ultrasonic inspection is preferred in many applications because it is generally fast, more accurate, and eliminates the need for direct contact with the test item. Warning! Wait, close your eyes now! Okay, just kidding about it. Now I will talk patient application. Ultrasonic testing can be used for variation of applications including flat detection, measurement of case hardening dependence, aversion and correction thickness gradient, estimate of fault contact incorporation. Here is the example of patient application. There are two examples here: thickness gauging and flood detection in well. First, thickness gauging in the photonic, chemical, and utility industry. Ultrasonic thickness gauging is often used to calculate variation degree of correction and aberration. And another one is application including PP system, storage, and contact filtering pressure vest. Next is flood detection in well. One of the most widely used methods of inspection when is ultrasonic inspection. Full perimeter cloth wetland then set ready to angle beam shape wave examination.
My name is Ammar Shahir bin Abbas with matrix number 143366 and I am from group 8. So now I will talk about the equipments for ultrasonic testing. Equipment for ultrasonic testing is very diversified. Proper selection is important to ensure accurate inspection data as desired for specific applications. In general, there are three basic components that comprise an ultrasonic test system, which are transducers, instrumentation, and calibration standards. Transducers are manufactured in a variety of forms, shapes, and sizes for varying applications. In selecting a transducer for a given application, it is important to choose based on the needs such as desired frequency, bandwidth, size, and in some cases focusing, which optimizes the inspection capabilities. For contact transducers, they are designed to withstand rigorous use, and usually they have a wave plate on the bottom surface to protect the piezoelectric element from contact with the surface of the test article. Many incorporate ergonomic designs for ease of grip while scanning along the surface. Contact transducers are available with two piezoelectric crystals in one housing. These transducers are called dual-element transducers. One crystal acts as a transmitter and the other as a receiver. This arrangement improves near-surface resolution because the second transducer does not need to complete a transmit function before listening for echoes. Dual elements are commonly employed in thickness gouging of thin materials. Ultrasonic equipment is usually purchased to satisfy specific inspection needs. Some users may purchase general-purpose equipment to fulfill a number of inspection applications. Test equipment can be classified in a number of different ways. This may include portable or stationary, contact or immersion, manual or automated. Further classification of instruments commonly divides them into four general categories, such as D-meters, flaw detectors, industrial and special application. D-meters or digital thickness gauge instruments provide the user with a digital or numeric readout. They are designed primarily for corrosion or erosion inspection applications. Some instruments provide the user with both a digital readout and a display of the signal. A distinct advantage of these units is that they allow the user to evaluate the signal to ensure that the digital measurements are of the desired features. Flaw detectors are instruments designed primarily for the inspection of components for defects. However, the signal can be evaluated to obtain other information such as material thickness values. Both analog and digital display are available. They offer the user options of getting horizontal sweep and amplitude threshold.
My name is Nur Shafika binti Saiful and my metric number is 141797. Next, I will present about the calibration standard. Calibration is the process of setting the parameters of ultrasonic test equipment to known values. This allows the inspector to compare test signals to previously recorded data. It comes in many material types and configurations due to the diversity of inspection applications. Calibration standards are usually made from materials with similar acoustic properties as the test products. The first one is for thickness. Thickness calibration standards may be flat or curved for pipe and tubing applications, consisting of simple variations in material thickness. For distance or area amplitude, with change in sound path from the entrance surface, use flat bottoms, holes, or side drill to establish known reflector size. Next, for angle beam inspection, it is used when flows are not parallel to entry surface. To define time distance and amplitude correlation, the standard use side drill holes, notch, and geometric arrangement. Next is for qualification standards. The applications is for verifying correct equipment operation and equipment qualification for specified codes and standards. Next, for data presentation, information and data from ultrasonic testing can be presented in three formats. First is A scan, second is B scan, and the third one is C scan. Next, for A scan, the amount of received ultrasonic energy is displayed as a function of time in an A-scan presentation. Relative discontinuity size can be estimated by comparing the signal amplitude from a known reflector. The position of the signal on the horizontal sweep can be used to get the depth of the reflector. For B-scan presentations display a profile view or cross-sectional of a test specimen. Only the reflector depth in the cross-section and the linear dimensions can be determined. A limitation to this display technique is that reflectors may be masked by larger reflectors near the surface. The last one is for C-scan. The C-scan presentation shows the test specimen in a plan view with discontinuities. Immersion scanning uses an automated data acquisition method to create C-scan presentations. When determining depth, the use of A-scan in conjunction with C-scan is required. There are some advantages of ultrasonic testing. The first one is the ultrasonic testing is sensitive to both surface and subsurface discontinuities. The depth of penetration for flaw detection or measurement is superior to other methods. Only single-site access is needed when pulse echo technique is used. The high accuracy in determining reflector position and estimating size and shape. Minimal part preparation is required. Electronic equipment provides instantaneous result. Detailed image can be produced with automated systems. And the last one has other use such as thickness measurement in addition to flaw detection. Last but not least is the limitation of ultrasonic testing. The first one is surface must be accessible to transmit ultrasound. Skill and training is more extensive than with some other methods. Normally requires a coupling medium to promote transfer of sound energy into test specimen. Materials that are rough, irregular in shape, very small, exceptionally thin, or not homogeneous are difficult to inspect. Linear defects oriented parallel to the sound beam may go undetected. The last one is reference standards are required for both equipment calibration and characterization of flaws.